Mute myself. All right. Thanks for opening that. All right, so here I am. All right, suppose that you were about to run some experiments by changing the batteries and bulbs in a flashlight circuit. Think about what happened to the current flow and thus the bulb. All right, so how would you expect the current to change if the original battery was replaced by one of higher voltage? What do you think? If it's had higher voltage, stronger current, so increased. Now, in current, they use as the letter I. All right, now if it had lower voltage, what do you think, McCain? It'd have a lower current. All right. All right, so if we had increased voltage and if we had decreased voltage. All right, now B. How would you expect the current to change if the original bulb was replaced by one of higher resistance? So resistance is like where it slows down the speed of the electrons. The electrons can't move as smoothly through the circuit. Had higher resistance. Neil? What? If you replaced part of the circuit with higher resistance. You don't know? Isaac?
It would be lower.
The current would be lower?
Yeah.
So increased resistance, decreased current. All right, so what if it had lower resistance then? So lower resistance, increased current, okay? All right, how would you expect the current to change if the original battery was replaced by one of higher voltage and one of lower resistance? So we increase the voltage, we decrease the resistance, and so what will that lead to with our current? Super strong, okay? So I'm going to put 2 arrows. Okay, what if the voltage decreased and the resistance increased? What would happen to the current then? What's that? It'd be really weak. Yeah, wouldn't be very strong. Good. All right, how would you expect the current to change if both the voltage and resistance were increased? All right, so let's say they were increased at the same rate. Increased voltage and increased resistance. Normal? What do you think? Nathan, you've been awful quiet. If we increase both the strength and the resisting force.
Neutral.
What'd you say, Kane? Stay the same. Very good. All right, so you should have read that, and I will upload a video probably whenever the homework for this is due that introduces multivariable variation. And so what this entire new lesson is on is where we have both direct and inverse variation in the same equation. Okay? So our contextual question, essential question that we're answering, what symbolic rules represent the relationship of current, voltage, and resistance in simple electric circuit? So that's our contextual stuff. And how can relationships among several variables be written in useful equivalent forms? So equivalent forms meaning it looks different, but it's still the same relation. All right, so now question 1. Has everyone had a chance to look through question 1 a little bit? No, we haven't?
No.
All right, here. You have, let's say, 3 minutes to decide among these 5 equations right there? Among those 5 equations, what would have this relation. All right. Okay. Go. Now, these are our options. And based on what we know, everyone needs to vote once. So let's see. There are 8. 8, 10, 13 of you. So I better see 13 votes, for goodness sake. This is not the presidential election where only a third of the populace votes. We're all going to vote. Okay. Who thinks this first one? V minus R? 2? All right. Second one? V plus R? The third one? V times R? The fourth one? V over R? 1, 2, 3, 4, 5, 6, 7, 8. And the fifth one? R divided by V. All right. So defending are 2 votes over here. Thoughts? Oh, this is 3. So let's see. That's 11, 12. We still didn't have someone vote.
There's only 12 people here. 1, 2, 3.
5 plus. Oh, there's no one sitting by Nathan. Fair enough. I stand corrected. There's no one sitting by Nathan. All right. Hey, counting's hard, guys. All right. Now, what's your defense over there? What do you think? What's your argument?
Like if you want to have like a really high current, you just have like a super strong voltage and really weak resistance.
Okay, so would voltage increase or decrease the current here? Did it increase it? Okay, what would resistance do? Decrease it. So that seems logical. All right, Nathan, what do you think? Just a guess. All right. Hey, I appreciate that answer. Now, the rest of you, so 8 of you, what do you think? V divided by R. Just yes.
Yep.
That's not an argument. So we think it's I equals V over R because Gabby? You're on the right track of thinking. You're on the right track of thinking. You definitely are. Sammy, what do you think?
I know along the same lines, like they're relating to each other, so when voltage is higher, the resistance is higher, then they're going to cancel each other out.
Okay. So besides the guess, it's about the relation. And that was also over here. And those are 2 very solid guesses. Now here is what we're going to do. We're going to check. Well, that's what we're about to test out, guys. I do not.
I'm in the box.
Go ahead. All right. So here's what we have. This little guy right here. And here with Ohm's law. So we thought it could be that equation or that equation. So we're going to do tests.
third one.
Oh, you want to give an example for the third test?
Yeah.
Okay, what would you suggest?
Well,
So-
let's test the third one.
Say again.
Test what the third one would be too.
Yeah, see, we're going to have 6 tests right here. So right here, we're going to be putting in different voltages and different different voltage and different resistance 6 times to see what the resulting current is. So who wants to volunteer voltage and resistance for the first one? Yeah, and please give me integers, so whole numbers, just so it's easier. 5 for voltage and resistance.
6.7.
We're going to do integers, so whole numbers. The second one,
Can I have that? Piece of paper.
right here.
8.
8, so 8 for the voltage or the resistance. And what's your resistance, Sammy? 3, okay.
100 for the next one.
Okay, that's going to take me forever. Let's say 10 and 1. Okay, so the fourth one, Clay.
6 and
6 and 5. All right, the fifth one, Isaac. 9 and 7. Kinsley, the last one. 4 and 2. We have a lot of these where the voltage is higher, so let's say 2 and 4. Let's switch these. All right, so now let's try these out. So the first one, my voltage has to be 5. And my resistance, this is a resistor right here. This is just a battery. My resistance is, it was already set on 6, wasn't it? Okay, turn it on. Let's see if it works. All right, what's the resulting amperage? Or the resulting, current? 0.83. Yep. All right, so now let's turn this off. Now we have to turn up the voltage to 8. Thank you, Jacob. And the resistance down to 3. All right. Are there predictions? What will the current be? You think it'll be 3?
Sure.
All right, let's try this out. All right, so what's the resulting current?
2.66.
Okay, let's try the third one here. Oops. So now we have 10 and 1. All right. What's the resulting current going to be? 10? Oh, or the bulb broke. Why did the bulb break?
Oh, 2.
What's the max current say? 3.5. All right, so now let's reset this. So 6 and 5. All right, does the bulb break or stay? Stays. Okay, let's test it out. Oop, that should be 5, not 1. My bad. There we go. So, and the current is 1.2. Now we have 9 and 7, right? Predictions. You think it's 1.2, Neil? 1.28. Let's try it out. 1.28. Okay. And do you have a prediction, Neil, for the last one? You think it's 0.5? How did Neil get that, guys? He divided. Okay. 0.5 indeed. So now what's our formula, guys?
It's the fourth one.
The fourth one?
Yeah.
I equals V over R. Do we all agree?
I guess. Yeah.
Okay. So now, use the language of direct and inverse variation. To explain in words how current varies as voltage and resistance change. So let's do this as a class. So let's see, if my voltage increases and my resistance stays the same, what's going to happen to my current? It's going to go up. All right. Now let's try this. Our voltage stays the same and our resistance increases. Our current will go down. What do you think? One person said down. It's going down. All right, so now, what if voltage stays the same and resistance decreases? Our current will go up. All right. All right, so now what if voltage increases and resistance increases the same amount? What will happen to stays the same? So now we're going to label these as direct or inverse variation right here. Voltage increases, resistance stays the same, and our current increases. So voltage and current are they direct or are they inverse? They're opposites. See how they're both go, if one goes up, so does the other? So that would be direct. All right, so what about resistance and current? Inverse, why do you say that? All right, so that would indeed be inverse. If they have opposite directions, they're inverse. And these, our voltage and our current, go the same direction. So those are indeed direct. Okay, so you will be using the information we have covered in questions 1 and 2 to answer questions 3 and 4. If you don't get questions 3 and 4 done, they are homework.
That's right.